In this video, I'm going to demo how we can use Unravel to increase developer productivity and application reliability by reducing query inefficiencies. Once you connect a BigQuery project to Unravel, all the queries of the project will be automatically tracked and analyzed for performance. Here we are looking at the jobs page of Unravel. In the center, we can see the list of jobs and the main attributes such as part of the SQL statement, the state of the query, the pricing plan, the resources that it used, the user, project, creation time, duration, and so on. You can sort the list of queries by any of these columns, or you can go to the left where you can use the filters to quickly identify the targeted queries. For example, if you already tagged your queries, you can filter your queries by the tags. We can also go to the Inefficient tab to look at only the queries that have insights and recommendations from Unravel. Unravel detects various types of query inefficiencies, like the famous select star, inefficient joins, such as cross joins or joins that result in data explosion, not using partition pruning when it is available, and many other anti-patterns that lead to poor performance, but most users don't notice. Let us look at an example. Here we are looking at the detail page of a query. At the top, you can see important metrics such as the tags, the duration, the resources that it used, the project and pricing plan, the user, etc. The full list of metrics is available in the Metrics tab here. The statement window, which can be maximized, shows you the complete query text along with the line numbers. The Data tab shows you the input and output tables. The Stages shows you the stages of the query run. And the Same Statement Jobs tab shows you the different runs that have the same signature as this run. A query signature is a SQL query without the constants. For example, if you have a scheduled query that runs multiple times, each of these runs may have different constants, but they all have the same signature. The most useful part of this query page is the Insights tab, where you can see the Unravel recommendations and insights. In this case, there are 3 significant insights that we want to look at. First, static queries in select is talking about that the expression in line 7 returns a set of static values and can be defined as a variable to make it more efficient. Here you can see that within this select clause, there's another select clause where this expression is being invoked, and this result is being added with another expression. So you can actually make this query more efficient by creating a separate variable that does this computation. The second insight recognizes that the cast function on line number 5 is actually not needed because the data is already of the required type. So the recommendation is simply to remove the cast function. The last insight is recognizing that this query has a left outer join with the where condition that has an expression with is null. This pattern can be rewritten so that you don't even need to join. Here, the recommendation suggests you to use not exist in an end and not use the join. Now let's take a look at the new query that has incorporated all these recommendations. It can be difficult to see how this differs from the original run. Unravel allows you to do a side-by-side comparison to make this easier. So I'm going to copy this query ID of the new run, come back to the original page, click on Compare Job, put in the query ID of the new run, and then you can see the side-by-side comparison. First, let us look at the query text. You can see that this expression with the coalesce is now being done separately as a variable, which in turn is being referenced in the original query. The cast function is also no longer used. And the last part, with the left outer join and the where clause that has the is now expression, is being rewritten into a nested query where the is null is turned into is not null, and the join is replaced by nested query with not exists. Now, let us check out the difference in performance. This query ran on the capacity-based plan. So what mattered is the slot time consumed. We can see that the slot time consumed went down from 1 hour and 18 minutes to approximately 54 minutes. Bytes build is actually a little bit more in the second run, but that's okay because this is only relevant if it's using an on-demand pricing plan. The wall clock duration went down a little bit from 35 seconds to about 31 seconds. While some of these recommendations are easy to follow, some can be challenging for average SQL users to know what to do exactly. Unravel is rolling out a new version that can leverage GenAI to generate actual query rewrites based on the Unravel query recommendation. Not only do we generate actual rewrites, but we can also verify the rewritten query to ensure that it returns the same number of columns and the same results based on synthetic dataset compared to the original run. Last but not least, we ensure that the rewritten query is actually more efficient. There are more details in this page that explains the query rewrite and the recommendations, which helps educate the broader team in your company and makes more non-SQL experts become experts.